Hi everyone, and welcome to this technologycatalog.com webinar. Today we'll be joined by Kasper and Andrzej from ReliaSol, who will present their predictive maintenance solution. Before we start, it's nice to say that ReliaSol was actually one of the winners last year in our Tech for the Energy Transition Awards, specifically in the category for maintenance. One of the key differentiators of their solution has been that they not only help end users optimize their maintenance strategy, but they also help improve safety, help reduce cost, and reduce CO2 footprint at the same time. So this has really helped them last year to be the winner. So today, I'm very much looking forward to their detailed presentation in this webinar. But before I hand over to Kasper and Andrzej, I would like to point out that if you have questions for the ReliaSol team, you can use the Q&A option and type your questions to them during the presentation. And then at the end of the presentation, I will pick up the questions and share them with the team. Without further ado, I would like to hand over to Kasper, who will present the ReliaSol solution. Kasper, over to you.
Thanks, Vincent. And well, of course, you already referred to it, so that we won last year the Tech for the Energy Transition Award in the maintenance category. So we're very proud of that. And actually what we thought of doing is in let's say the next 25 to 30 minutes or so today is to show a real life case study of how we actually used those award-winning capabilities for a project where until then getting predictive insights was not possible. So next slide, please. So, well, fortunately, I'm not going to be doing that completely by myself today. So I'm joined by Andrzej. He's leading our data scientist team. And also he was directly involved actually in that project that we're going to talk about. And therefore he has some very unique insights that we're going to share with you. And myself, I'm Kasper, and I'm responsible for sales and marketing at ReliaSol. Next slide, please. So today we thought of discussing more or less 4 topics. So I will start with providing an overview of the maintenance landscape in 2022. Then we'll briefly touch upon what actually is a predictive maintenance platform. And then we'll go quickly to the core of the presentation. So we'll really go to the case study for that energy production company, PG&IG. And then finally, of course, we're also actually going to answer the question that we ask ourselves in this webinar. So is AI-driven predictive maintenance always data heavy, or can it also be light and easy? So if you could move to the next slide and then just move to the next page. So probably a good idea, we thought, if you start to talk about the maintenance landscape, is to first start with the problems as we hear them from the companies that we speak with. So of course, well, we are a predictive and prescriptive maintenance company, so that means that very often the conversations start with those companies about their increasing maintenance costs or the downtime costs that are increasing for them. And in the end, then you've got the bigger problem. So how do these 2 issues make them actually miss their productivity goals? And well, of course, these are very likely topics for us to discuss with those companies. But at the same time, we've also noticed that, especially in the last period, that the health, safety, and environmental departments also become much more part of those conversations. And that's actually because the deliverables that those departments have are a very fundamental part of the business case, or actually the return on investment for a company when they consider implementing predictive or prescriptive maintenance. Next slide, please. And this is maybe a chart that you've seen before, but we like it, so that's why we also chose to use it, because we think it nicely captures the maintenance evolution in one chart. And if you start on the left, and obviously maintenance, it has always taken place, but in the beginning it was purely reactive. So you only act when something's happening. So that means that actually the problem is already occurring. Well, this has evolved via preventive measures into maintenance when there's measurements that show that it's necessary to perform maintenance. So then you're talking about condition-based maintenance. But the companies that we speak with and the companies out there, they're looking for more. And what they also want is that with a certain accuracy, they want to know in advance when something will go wrong. And that's why initiatives have been developed that can predict on the basis of data when something will go wrong, but also why it's going wrong. And this is what you call predictive maintenance. And then the last step in that evolution overview is prescriptive maintenance. And this is a technique that will also tell you what should be done to prevent failure from happening in the first place. Next slide, please. We guess that many of you know that predictive maintenance and prescriptive maintenance are associated with artificial intelligence or AI. So these terms are probably somewhat familiar, but maybe just to go through very, very quickly. So with AI, that means that you use software or computers that start to think like people, but then maybe very simply put, just with a much larger brain. If you talk about ML or machine learning, that's where you make use of algorithms to ensure that these systems, that they become self-learning. So they can actually learn from things they have, let's say, experienced before. And finally, the term deep learning, that refers to the situation in which you have neural networks that are used to handle very large data sets. Next slide. So if you then go back to that maintenance landscape, but look at it differently, so look into 2022, then you do see there's actually still numerous possibilities out there to deal with maintenance. And in this overview, we wanted to compare the value, so of the vertical axis, with the complexity on the horizontal axis. And what you see on the bottom left is that actually traditionally still a lot is done with pen and paper. And if you professionalize that in some way, to put it like that, well, I guess the next stop is probably something like Excel. But of course, these type of solutions, they have relatively little value, but also they cannot be standardized and they will cost a lot of time. So from a resource perspective, and those are the hours and days that you could also use differently and more effectively. And that is why toolkits have been developed, and they do make things a lot easier, but they still provide relatively little insight into the maintenance options that you have. Because after all, at that point, you still don't know yet when is something going to happen, why is it happening, and also what can you do about it. And that is when you move to the top right quadrant, what the role of predictive and prescriptive maintenance is. And if you link that back to the previous slide, so the AI summary we gave, then predictive and prescriptive maintenance, that is where you actually make use of AI, where the other solutions will not. And that is because with predictive and prescriptive maintenance, you actually have the algorithms and the predictive models to predict what will happen, what causes it, and also what can you do about it. However, and if you could move to the next update for this slide, please. Yeah, thanks, Martina. You can also see that there's two gaps on this overview. Well, the bottom right, if you don't have anything there that you can think of, so low value and high complexity, that's good. If you have something that you're doing there, please stop doing it, because this is probably not where you want to spend your money. But also on the top left, so actually where the complexity is low, but the value is high, that's also where there's a gap. And that's what we're going to talk about today, because that's where, with this case study, where we develop something specifically. Next slide, please. Thank you. If you could move. Yeah, thanks. So if we then very quickly spend a minute on looking a little bit more detail of what a predictive maintenance platform actually is and what the pros and cons are. Well, to make a very long story short, a predictive maintenance platform offers a very wide range of tools to optimize a process, and it's based actually on process data. But there are certain things that you need to take into account. So first of all, it all starts with, but also ends with, the availability of high quality data. But also, if you have the data, then technically it's often very well possible to implement a predictive maintenance platform. But it doesn't mean that from a business perspective, it actually makes sense to do so. So we really urge people, companies, to make sure to spend enough time on the ROI expectations. And also on one of the first slides, and actually I spoke about how nowadays many departments directly benefit from predictive maintenance. So for instance, that health, safety and environment department. And of course, that's great, but that also means that there's the counter effect of that. So there's going to be more stakeholders and more decision makers. So typically that means that the implementation or the decision making also will become a little bit more complex. Next slide, please. So in summary, that means that a predictive maintenance platform, how we see it, is the best there is when you'd like to not only predict failures and other events, but also you're looking to have the specific identification of the place and the form of the failure. You would like to know when will the failure take place. You would like to have your root cause analysis and recommendation for preventive measures. And also, it will allow you to further optimize your processes, and it will simply provide you with the highest accuracy. However, there are certain things you will not get around if you'd like to implement such a platform. And first of all, because it is typically a very bespoke solution, so therefore you can probably understand that there's a relatively longer implementation time. And to be able to build those predictive models that you can make use of, you do need to have significant amounts of data. And because of this combination, so that implementation project, but also those data requirements, the upfront investment is not insignificant. On the other side, the ROI is great, but you will need to make some investment at the start. Well, and of course, because you make use of that great computational power, that also means there are some IT requirements that need to be taken into account. Next slide, please. So we thought, well, what if this is actually a bit too much? So isn't it possible to make it easier? You can move through the next slide, please, Martina. So let's start talking about the business case. So, well, actually, what we found is that it is possible to make it easier. And what we're going to go to discuss now is that project that we've done for one of the leading European energy companies, which is PG&IG. And more specifically, we're talking about PG&IG Thermica. They are a market leader in heat and electricity production in Europe, and they're actually the second largest producer of heat and electricity in cogeneration in Poland. And what is nice to know is that they actually cover roughly 65% of the total demand for electric energy in Warsaw. And with that, as I promised at the start, I'd like to hand over to Andrzej, who will really go to the core of the presentation, where we will discuss in detail what we've done at that project and also what the outcomes were. Andrzej?
Yep. Okay, so thanks, Kasper. And next slide, please. Okay, so the project for PG&IG included a new installation launched in 2021. And in the project, we mainly focused on important parts of this installation, for example, fans, pumps, burners, combustion chamber, and some other installation and machine. And due to the fact that there was no failure and critical problems in the data, and there are not enough historical data because of childhood of the installation, together with the client, we define the problem for us to find and define some anomalies, some potential problems in the data. So here we cannot use our main technology, so standard PDM solution, because of the lack of the data, and no problems. And after a quickly check of the process data, so what we have, together with client, we decide to detect some anomalies. And to do it, we use two techniques. So the first is classical unsupervised learning, which offer precise information about the problem, about the anomalies. But it's difficult to make a good explanation and interpretation. It's like a gray or black box model. So the second approach is based on statistics, and this allow us to make some explanation at the low level that is understandable for the maintenance guys and for end user of our solution. So next slide, please. So today, I would like to mainly focus on the statistical approach and how we define the potential anomalies. and the most important case of it is the first one is the out of range values. We treat it as like a one-dimensional anomalies, rapid increment of measurements or in sensors, finding the trends, changing the measurements characteristics, and losing correlation, some statistical behavior. So today I would like to make some explanation about it and why we define these 5 types of anomalies, because each of them allow to make some alerts, get the information about changing something in the data. And on the next slides, I present some examples. So please, next slides. Okay, first example is connected with the threshold anomalies, this one-dimensional anomalies. So the standard monitoring system uses the limits given by the expert. So it's like the technological limits given by the producer. And in most cases, the process is far from these boundaries. For example, the level of vibration is 1 units, and the alert is at the level of 12, 15, or something like that. So it's far from it, and if something change, we not find it quickly, and only we can monitor some behavior. So in our approach, we use the technique based on statistic and machine learning, and calculate limits based on the information about the current state of installation. So for example, if the limit is 10, we calculate, make some statistic, and we decide to get the limit at the level 5. So this technique allows us to inform about change faster than the classical limits. On this slide, we can see the level of vibration. So in history, we've got it between 0 and 2. And in some moment, we've got some increment at the level 3.5 millimeters per second. It's not big increment, but it's something different than in the normal work of installation. So, so this tool inform about the potential changes, potential anomalies faster than DCS system. Next slide, please. Okay, the next approach is finding some changes in the signal, in behavior of this signal, and this approach also allow user to find situation when the process change their behavior without changing the process parameter. For example, operator make some changes in the steering, so it's natural that the signal change. But on the other hand, if operator not change anything and the signal change, it's connected with some potential anomaly. Here we can see that they reach the threshold, and also if we look at the variation of the signal, it's also rise. So it's our algorithm find this situation and inform about potential problem, because when we speak about the anomalies, every time it could be potential problem. Okay, next slide. Okay, the next problem that we can have in the data, in the process data, is the trend. Here we can see we observe the trend on the vibration level in one of the cases, and also the level of vibration is not high, but it slowly grows. So the continuation of this process in this case the rising, in some other cases falling down, may cause some changes in the process at the next stage or lead to damage the installation. So again, information about it at the early stage, together with the estimation when the limits could be reached. So this technological limits and this setting by us allow user to make some operational changes and stop this unwanted behavior. Next slide. Okay, the last case is a problem of losing correlation or some statistical behavior in the signals. So here we can use two approaches. First is finding sensors which are correlated or associated, and then monitor losing of these dependencies. For example, we focus on temperature in electric engine and motor, and monitor differences or correlation level, and then calculate anomaly score. So this is the classical approach. And the second one, we can combine together real data and the simulation coming from some numerical model. For example, it's like a digital twin. So we've got the model that can simulate the behavior, and we can compare the real data and the data from digital twin and calculate anomaly score. So here we show you the real data, the red one and the blue one, which is prediction, and here we can see some part where the anomaly score is big, because the differences, the algorithm that calculate the anomaly score finds some differences and highlight it. Okay, next slide. Okay, to sum up everything in this project, we've got 100% verified anomalies finding in the data. So the approaches that we present and some other approaches, we decide to implement it to increase the quality of monitoring system. And the next step, so is launching a demo version of this application for clients, validate the results of the data coming from the new periods, so new data from incoming season, and roll out for other installation. Okay, that's all from my side. Kasper, the floor is yours.
Okay, thank you, Andrzej. Martina, if you could go to the next slide, please. Yeah, thanks. So in the end, what this means is that with these apps and with this project for PG&IG Thermica, we were able to provide a solution that is truly unique. Because first of all, because of the speed of implementation, as we explained, it does not require any large data set. It's super scalable, and also the costs are fundamentally different than what you would see typically in your predictive maintenance platform. Next slide, please. And well, as you can also see in this quote from PG&IG, they were very happy with what we brought for that project, because it allowed them to start this project without actually having that historical data, and still get the critical insights from their assets. And maybe to even go further with that is that actually they were so happy with the outcome of this project that we are not only started to talk about next project, but they also decided to invest in us as a company. So really believing in this solution for the longer term as well. So if we could go through the next slide. Yeah, thank you. So to go to the conclusion, so as I promised, we would also try to answer the question that we actually asked ourselves at the start. So is AI-driven predictive maintenance always data heavy, or can it also be light and easy? Well, the honest answer is AI-driven predictive maintenance will probably never be truly extremely easy, but we do know that it can be much simpler to implement, and also much more accessible. So that means accessible to companies that wouldn't be able to use predictive maintenance before. What's very important is that when you consider your options, you need to look at your business objectives, but also look into what are you looking for prediction time horizon, what do you need for minimum accuracy. And the correct route for you will be determined by the availability of having the right data. So if you think about the apps, then you can get insights into crucial variables. And for some, that's going to be just a starting point on the way towards a platform. But for other companies, this will actually be more than sufficient information. And that's because, well, in the end, they are fast, they're scalable, they're independent of the IT/OT systems, and the costs are lower. But also, we know that there's companies that will continue to look for more. So they will need further functionality that indicates the failure types, root cause analysis, and can help with providing recommendations of preventive measures. And that is where we see that with this new type of product, so this app, it is really the ideal first step towards full predictive maintenance. Because now for the first time, you can actually take totally risk-free, you can take that first step, see what is the data that you have, that you generate, what does it do for you, and does it actually make sense to then later on move to a predictive maintenance platform, or are you happy with the insights that the apps are giving you? So with that, with a couple of minutes to go, I'd like to thank you for your time and interest, and well, maybe to see if there are any questions from the audience that we can answer.
Thanks, Kasper and Andrzej. So great to see. Actually, the first questions have already come in. So actually, we have two questions from Graham. So the first question is, what's the USP of ReliaSol's products app as opposed to the very many vendors that are on the market already?
Yeah, so I think that it really is, at least Andrzej, if you're okay for me to take this, it is the combination. So the starting point of this company was the predictive maintenance platform that we have. So let's say where we really have the core strength of our company, where you look into not only the engine, but the fact that we have automated more than the other solutions out there, but also that if you look into our technical team, then it's not only Andrzej's data scientist team, but we also have the process engineers, the mechanical engineers, the electrical engineers on board. And what we've done is actually, from that platform, we have, let's say, separated certain modules that we translated into these standalone apps. But we still make use of in the background of our platform for the calculations. So I would almost say, what makes us special is the fact that these entry-level products, these apps, they are still based on that industry-leading platform that actually allows us to win prizes and do all those great projects.
Okay, thanks. And actually, yeah, the next question links to something that also triggered my curiosity. So we have a lot of end users that are already working with a range of tools in the maintenance space. So another question from Graham was if your solutions are purely standalone, or if they can be integrated with third-party solutions or even the client's in-house solutions that are already being used.
Yeah, the answer to that is yes. As in, we can integrate with everything. So what we do is actually we have deployed projects not only with end users, but also via business partners, as we call them. So let's say integrators or other platform providers, and even OEMs. And you will see that depending on what they are looking for, then the question comes up. So do they want us to provide the full platform with the dashboards provided, or is it only, I would say, let's say, for us to do the calculations in the background and then send the data back to them?
Okay, and that's I think I recall from your slide, the API side in your model, right? So okay, yeah. Hope that answers your question, Graham. So any of the other attendees, if you have a question, please type them in the Q&A section. In the meantime, actually, there was one other question that you triggered is, I think, yeah, based on your presentation, I can see you offer a great solution for those that want to get started with predictive maintenance. Can you also say something about the implementation time that the total implementation time of the product project that you discussed? Because I'm not sure if you presented it or I may have missed it. Maybe Andrzej, you can say something about that.
So from the beginning, so the NDA and without NDA and some processing time, the small project that we can use the apps and this technique, it can took just about 1 month or something like that. It depends on the big the number of sensor, number of installation, but a lot of stuff we've got the automatic, so we can look at the data, make our algorithms, and get the results. Yeah, Kasper, would you like to add something?
No, I agree with what you say, and I think that because actually it's a very good question from Vincent. Unfortunately, there's not one straight answer to that. I would say that maybe to make the difference between platform and the apps is that when you talk about platform, then typically because of the data requirements that you have also there, you're talking about months of an implementation project, and it could very well be that it's on the data preparation side from the customer, or simply gathering the data still. If you talk about the apps, so not that project with PG&IG, because that's where we actually developed those apps, but if you look into, let's say, the apps as a ready product, then you should think actually in days or weeks, assuming that the data that the customer is generating, that it can be fed into the apps.
Okay, clear. Yeah, I think I'm really pleased that you guys presented this today, because I can also see many of the end user clients that we work with, they want to move into the predictive maintenance space, but very often, to prove the business case, they have the first challenge at hand, and that's legacy data. So I think your apps offer a very nice way of essentially testing the business case without having to go through all that. Actually, linked to that, maybe I don't see any other questions, so I'll take the liberty of perhaps the last question is that, do you guys see this, where do you see the future? Do you see it more on the app space so that you can almost forget about your legacy data, or is that maybe, too bold of a statement?
No, I think it is, it's a little bit, maybe too black and white, to put it like that. So we do see that for the apps, it allows customers or companies that normally would not even be able to think about predictive maintenance to get those predictive insights. So for them, actually, it will stay at app level. But at the same time, we also know that there are companies that do need to know more. So they are actually looking for maybe also not only predictive maintenance, but the next step, prescriptive maintenance. They would like to go to process optimization. And that is where you will then typically go to, let's say to the platform. It's also in the end related to not only the cost of implementation, but also the cost of sensors, the cost of computational power, of the data availability, because that's where you also see that in the last couple of years, let's say the industry as such has been making really big steps. That there's simply a lot more projects that can be deployed because the data is there, the computational power has become a lot less expensive. So that opens up the market as well, or the world for predictive maintenance platforms.
Okay, yeah, and I think I'll allow one last question because I think it's linked to this that came in just while we were talking. And that is, how is and where is your platform hosted? Is it in a common cloud provider? Because again, it's something I recognize. I see a lot of our clients asking the same question around this, is of course about their concerns regarding their data storage and location. So are you flexible in terms of cloud services, or do you have a fixed partnership with one of the cloud providers?
No, we are flexible there. So we do offer in the cloud. So indeed, AWS and Azure are probably the main ones. We have our own private cloud. Sometimes our customers have their own cloud. But just like this PG&IG project, we actually have done quite some project in the energy market. And that is where you will typically see, just because of security reasons, it must be on-premise. So that's not a problem at all for us. It's just, let's say, an implementation question that needs to be addressed.
Okay, thanks very much. And so I also like to thank everyone for joining. There was a practical question that came in, if the slides can be shared. So yeah, Kasper is nodding, so that's something we will normally ask the suppliers. That is your content, so we'll make sure that's shared with all the attendees. So thanks for everyone that joined today. Thanks for Kasper and Andrzej for giving this very interesting presentation. And we hope to see all of you again for one of the next webinars. And in the meantime, you can find more info also on the ReliaSol, but also other solutions on the platform, of course. And if you have any further questions, you can always reach out to Kasper or Andrzej just via their tech page on technologycatalog.com as well. And for now, I wish you all a great day wherever you are. Bye-bye.
Thank you. Bye-bye.
Thank you. Bye-bye.